Greetings of the day, dear students. Welcome to the Transformers class. In this video, we are going to discuss about the principle of operation of single phase transformer, and I will discuss the introduction about the transformer, and we will go into its principle of operation with the help of one diagram, and we will explain the circuit diagram symbol, right, and various terminology with related to the transformer and its principle of operation, and also about the some assumptions made for ideal transformer. What are the different assumptions we will consider for ideal transformer? Based on that, we will discuss some voltage ratio and transformation ratio, and also we will look into a small example, right? Yeah. Now coming to the transformer, most of the times everybody might have seen this transformer in the practical and real world scenario, right? So simply remember, it just simply transfers electric power from one circuit to another without any change in frequency. This point is very important, dear students. It just simply transfers the power, right? That too, it will happen without any change in frequency. How do you understand that word, without any change in frequency? If the input supply frequency is 50 Hz, the output frequency, the output power frequency will also be at the 50 Hz, right? So all this will happen by electromagnetic induction principle. And moreover, in this transformer, the two circuits will be magnetically coupled and they are electrically isolated. I repeat again, they are magnetically coupled and electrically isolated. And if you observe, there won't be any moving or rotating parts in a transformer, right? So it is a static device. The main feature, it is a static device. It won't move, right? And also the losses in transformer will be very low. Because of that, what happens is the efficiency will be very high for a transformer. And also the life of the transformer is very high, and it is also a robust and static device. So these are the some of the features of a transformer. I repeat again, dear students, it transfers power from one circuit to another without any change in frequency. It is a static device and the losses will be very low and its efficiency will be very high, and it is going to have a long life, and it is a robust and static device, right? Now let me look into the principle of operation and its symbol. This is the symbol, electrical equivalent symbol for transformer. Just you will represent some two windings, primary winding and secondary winding. In between that, you will draw some two parallel lines, right? And here, if you observe, it will have a primary side winding and secondary side winding. Nothing but a wire wound in the form of a coil, right? And primary side winding having N1 turns, and secondary side winding having N2 turns. Clear? Now these are the variables. V1 indicates the primary side voltage. I1 this one, I1 indicates the primary side current. V2 indicates secondary side voltage. This is the voltage. And I2 indicates the secondary side current. I2, this I2. So these four variables, V1, I1, V2, I2. Now phi indicates the flux linking both primary and secondary circuits. So this flux phi will be established, which will be linking both the circuits, phi, right? So as and when a current or a voltage is applied to the primary side winding, some current will be flowing through the coil. And because of this current flow, some flux phi will be established. And this flux phi will also link the secondary winding, and which is of having some N2 turns. Because of this, some EMF will be induced in the secondary coil. This is how it works. Clear? Yeah. Now if you observe, these two circuits are not joined electrically. They are just magnetically coupled. The flux established in one circuit is linking the other circuit. They are not electrically connected to one another. They are electrically isolated and magnetically coupled. Electrically isolated and magnetically coupled, right? Yeah. Now what happens is, when some voltage V1 is applied on the primary winding, as already the secondary winding, no load is connected, there is no load yet connected, the secondary winding is open circuited. Because of this, a small current called no load current, the current flowing in the secondary winding, right, there is no load, not yet any load connected, no load current, and this will set up some magnetic flux in the core. And as I told you, this flux will link both the primary and secondary windings, and it will induce EMF E1 and E2 by mutual induction. And now that induced EMF is given by this formula, very important, E equal to minus N. How much voltage will be induced? You may get a doubt, how much voltage is induced? It depends upon the number of turns and the rate of change of flux linking the winding, 5, right? Yeah. E equal to minus N into d phi by dt. Here what does this negative sign indicates? This indicates that the induced EMF opposes the change in flux. Very important. Whatever EMF is induced, it is going to oppose any change in the flux. Because of that, you will use a negative sign, and it is given by the Lenz's law. Clear? E equal to minus N into d phi by dt. The negative sign indicates the EMF opposes in the change in the flux, right? Yeah. Now there are some assumptions to be made, dear students. Observe, as I have told you, the primary and secondary were having the windings. Winding means nothing but a wire, just a conducting material wound in the form of a coil. The moment you say a electrical conductor or conducting material or wire, obviously it will have some resistance. The winding resistance is negligible. No leakage flux. That means whatever the flux generated in the primary winding, the entire flux is going to link the secondary winding. No flux is getting leaked into the air or surroundings, like that. No leakage flux. And the permeability of the core is high. So if the permeability of the core means nothing but this coil will be wound on a material. On which material it is wound, that material will have its own permeability. Now depending upon the permeability of the core and depending upon how much amount of current is flowing, the flux will be established around the coil. If permeability is very high, for small amount of current we can get the same amount of flux. Like that you have to understand. I repeat again, dear students, understand, if permeability is high, right, so it requires minimum current. For a very small amount of current we can get more amount of flux. Like that you have to understand. If the permeability is very low, then you have to supply more current to get the same amount of flux, right? Yeah. So here and one more thing is losses. Exclusively we are having one topic on the losses where we will discuss the different types of losses in the transformer. But now remember, this hysteresis and eddy current losses are negligible. These are the 4 assumptions we can make for an ideal transformer. Clear? I repeat again, dear students, winding resistance is negligible. No leakage flux. Permeability of the core is high. And hysteresis and eddy current losses are negligible. Right? Now, for ideal transformer, whatever flux, this change in flux with respect to time is same for both primary and secondary. Clear? Yeah. Now let me see, dear students, how much EMF is induced in the primary. It is given by E1 equal to minus N1, number of turns in the primary, into rate of change of flux d phi by dt. Similarly, EMF induced in secondary, E2 equal to minus N2 into d phi by dt. Now from the assumptions, d phi by dt is same for both the primary and secondary windings. Then what happens? Observe, E2 by E1, the voltage induced in the secondary divided by voltage induced in the primary, is equal to N2 by N1. Very important, dear students. Very important. You may get a doubt here, sir. We are having V1 and V2 and E1 and E2. Observe, dear students, in this diagram, V1 and V2, this is the applied voltage, and V2 is the voltage across the load. Now, because of this applied voltage V1, here voltage induced E1 denoted with letter E. Now, because of this induced E1, some voltage will be induced in the secondary E2. If there are no losses, this E2 will be equal to V2. Whatever voltage is induced here, that will be available across the load when conditionally if there are no losses. Very, very important, dear students. E1 is the induced EMF in the primary. E2 is the induced EMF in the secondary. If there are no losses in the transformer, this entire voltage will be available across the load. Like that you have to understand. Clear? Right. Now, observe, if there are no losses, what will happen? That E2 will be equal to V2. V2 by V1 equal to N2 by N1 equal to K. Very, very important, dear students. In objective bits, they will be asking voltage ratio or transformation ratio. K is called what? Voltage ratio or transformation ratio. Voltage ratio or transformation ratio. Now, what happens if number of turns, for example, if you are having a primary turns like this, and secondary you are having more number of turns, this side you are having only some 50 turns, and this side you are having some 100 turns, secondary side. Now which side the turns are more? N2 side the turns are more, N1 side the turns are only 50. Based on this, what you can say, 100 by 50, V2 by V1 will be equal to how much? 100, N2 by N1, 100 by 50, that will be equal to 2. Your secondary side voltage will be 2 times the primary voltage. So there is a step up, there will be a step up in the voltage. The voltage will rise in the secondary. Like that you have to understand. Clear? Based upon the ratio, whether N2 is greater than N1, then it is called step up transformer. If you want to understand, you take any two random numbers, whole numbers, you take its ratio and observe. I have taken N2 as 100 and N1 as 50. Its meaning is the secondary side winding, there are only 100 turns. The primary side winding is having 50 turns. Now our secondary side voltage V2 will be how much? 2 times the V1. Like that you have to understand, right? Similarly, N2 is less than N1. If number of turns are in secondary or less than number of turns in the primary, right? Then it is called step down transformer. Step down transformer. Clear? Dear students, one more important point observe. Whatever power, for example, there will be change in the voltage levels, but the overall, if the power input, there won't be any change in the power. There should not be any change in the power. For example, if you are giving some 100 watts as an input, output also, of course, ideal case, if it is perfect case, you should also get 100 watts. So for power formula, you know, V1, I1. For output, what are the voltages and currents? V2, I2. Right? If there are changes in the voltages, the overall V and I must be constant. So in such a way, current will also get adjusted. Current will also get adjusted. Secondary side, there is an increase in the voltage, but this 100 must be constant. Then what happens to current? It will decrease. If there is an increase in the voltage in the secondary, what happens to the current compared to the primary? The current will decrease because this power must be constant. If it is ideal. Of course, there will be some losses. Whatever you give to the transformer, 100% you will not get it as an output across the transformer. Some losses will be there, right? Yeah. So to make you understand, V2 by V1 equal to N2 by N1 equal to K. Clear? Now, if there are no losses, what should happen to the transformer? you are having like this. At the input side you are giving power is V1 I1, and as it is you should get it as an output V2 I2 power. So then efficiency will be how much? This is output and this is input. Efficiency we will define it as output power by input power. If both are same, exactly same, then efficiency will be 100%. If power output is same as power input. Clear? Yeah. V1 I1 equal to V2 I2. V1 by V2 equal to I2 by I1. Right? So, but already we have seen V1 by V2 is what? N1 by N2. N1 by N2. But just now in the previous contest you have seen N2 by N1 is K. N2 by N1 is K. So N1 by N2 is nothing but 1 by K. It is 1 by K. Clear? So this is all about the principle of operation of the transformers and some of the assumptions, right? So please keep in mind, dear students, a voltage step up transformer, step down transformer, this condition is important. If N2 is greater than N1, step up transformer. If N2 less than N1, step down transformer. Okay, K greater than 1, K less than 1, and this equation E equal to how much voltage is induced, E equal to N into d phi by dt, and I have told the major, I have indicated here V1 E1. V1, this much of voltage you will apply, and E1 is the induced EMF in the primary. If there are no losses, as it is input voltage, we can observe as induced voltage. Similarly, E2, voltage induced in the secondary. V2, voltage available across the load, right? Yeah, primary side, secondary side. Phi is the flux linking both the coils, like that. These are all the basics. Now, a transformer, an ideal transformer has turns ratio 5:1. Turns ratio is given. Observe, primary current is 6 amps. Applied voltage 220 volt. Calculate secondary current and voltage. What is asking? Secondary voltage and current. Observe, dear students, primary current I1 equal to 6 amps. Primary voltage V1 equal to 220 volt. Turns ratio equal to 5:1. You please write down the data given. Whatever the data is given, using its variable names, please write down all the data given. Clear? Yeah. Next, go to the secondary current I2. Secondary current I2. We don't know that. Secondary voltage V2. We don't know that. Turns ratio is given. TURNS, turns ratio N1 by N2 equal to V1 by V2 equal to I2 by I1 equal to 5 divided by 1, because he gave you the turns ratio as 5:1. Its meaning is 5 divided by 1. That is what we have written here. Clear? So far clear? Turns ratio 5 divided by 1. Now we want I2. I2 will be simply I1 into 5, you just cross multiply. I2 equal to I1 into 5. So your secondary current I2 will be 30 amps. Now what about voltage? Voltage V2 equal to, observe here, we know here V1 by V2 equal to 5 divided by 1 from the data given. Now I want V2. That implies V2 equal to V1 by 5. Simple. That is what we have done here. 220 by 5. 44 volts. That is, for example, if you are having a transformer like this, how much current we got now? This current I1, this voltage V1, this current I2, voltage V2. I2 we got 30 amps. I1 already he gave how much? 6 amps. V1 already he gave 220 volts. What will the voltage V2? It is simply 44 volt. Like this you have to understand. So input is 6 amps, 220 volts. Output current how much we are getting? 30 amps. Voltage is 44 volts. Is it a step up transformer or step down transformer? Step down transformer. 220 volts became 44 volts. But current observed, it became very high. Turns ratio. If it is 5 turns, 5:1. Now, what is the input power? V1 I1. If you want power, V1 I1. 1.32 kVA. Now, what will be the resistance on the load side? V2 by I2. 1.466 ohms. Minimum resistance on load side, neglecting the losses. V2 by I2 equal to 1.466 ohms. So this is what all about the principle of operation of the transformer. Clear? Okay, please remember primary side voltage, primary side current. Secondary side voltage, secondary side current. Transformers just transfers power from one circuit to another without any change in frequency. There will be change in the voltages and current levels depending upon whether it is a step up transformer or step down transformer. Ideal assumptions for transformer are some assumptions we made. Winding resistance is negligible, no leakage flux, permeability of the core is high, and hysteresis and eddy current losses are negligible. If these points are highlighted while attempting a question from this topic, you will get more marks. Okay, thank you.